Today we are reviewing Pythagorean theorem. Pythagorean theorem is only used on what type of shapes? Right triangles. So it only works on right triangles. Pythagorean theorem can be used for two things. The first thing it can be used for is to find the missing side of a right triangle. And the second thing it can be used for is to see if something is a right triangle. So let's go ahead and look at it. The formula for Pythagorean theorem is a squared plus b squared equals c squared, and this is found on your star chart. Very good. All right, here we go. It is important to know what the pieces of a right triangle are called. The two sides that form the right angle are called the legs. So everybody draw a right angle right here. This is the right angle, so this is a leg, this is a leg. We call these sides A and sides B. Does it matter which one is which? No, so you can label either one A or B as long as the legs are called A and B. The side across from the right angle is always the side C, the hypotenuse. This has to be the C. You cannot mix that up. If you do, the whole problem will be messed up. The hypotenuse is always the longest side as well. Once you know this, you simply plug the numbers into the formula above and solve. So let's look at example 1. Find the right angle with your finger. Which angle is the right angle? Right here. How do you know it's a right angle? Because it makes a square. So this is the right angle. That means the side across from the right angle has to be side C. And then the other two are A and B. And again, it does not matter which one you do, A or B. Then you simply write your formula. A squared plus B squared equals C squared. And you plug in what you know. We know that A is 3, so I say 3 squared plus, we know that B is 4. 4 squared, and we don't know C, so we just say equals C squared. When you're solving for C, you add. When you're solving for A or B, you subtract. Right now I'm solving for C, so I'm simply going to add these together into my calculator. So I do 3 squared plus 4 squared, and I get 25. But that is not side C. That is C squared. Everybody understands that, right? That is basically the area of a square if I drew a square over here attached to side C. So the last step of Pythagorean theorem is to square root your answer, and that will give you C. And the square root of 25 is 5. We good? Everybody know where the square root button is, right? Right here above this in blue. So you have to hit second and then that. All right, flip it to the back. Everybody find the right angle. Did everybody find it? The side across from the right angle has to be side C. Okay, label the other two A and B. And then write your formula. A squared plus B squared equals C squared. And then fill in what you know. So I don't know A, so I say A squared. Plus, I do know B is 12 squared equals 13 squared. I can't add because there's nothing over here. That's why I said when you're solving for C, you add, but when you're solving for A or B, you subtract. So I'm going to do 13 squared minus 12 squared. So I go to my calculator. 13 squared minus 12 squared is 25. So I have A squared equals 25, but that is not side A. Remember, A cannot be bigger than C. So that's the area of a square over here. So I have to square root that, which happens to be 25, which happens to be 5. Just a coincidence that it was the same as the last one. Any questions on Pythagorean theorem and how to use Pythagorean theorem to solve for a missing side? Now let's look at how do you use Pythagorean theorem to tell if something is a right triangle. So in this one, you're not solving for anything at all. Do y'all understand that? They give you 3 sides of a triangle. You're not solving it. you're saying, yes, it's a right triangle, or no, it's not. And so the way to do this is simply to see if it's true or false in your calculator. So based off of this, we know that side C would have to be the biggest number. This would have to be the C. So I would say, is 3 squared plus 4 squared equal to 7 squared? I am not solving, no, 3 plus 4 is 7. 3 squared plus 4 squared, we have to see if it's equal to 7 squared. Okay? Don't just say 3 plus 4. It's 3 squared. A squared plus B squared equals C squared. All right, so all I have to do is type the left side in my calculator and then type the right side in my calculator and see if it's true. So everybody get your calculator. Type in 3 squared plus 4 squared. Hit enter. It's 25. Type in 7 squared. Hit enter. It's 49. So does 25 equal 49? No. So this is not a right triangle. Did I use my square root button? No, because I'm not solving anything. I'm just typing it in and seeing if it's true or false. All right, let's look at this one. If this was a right triangle, which one would have to be C? 30, 40, or 50? C has to be the biggest. So this would be A, B, and C. And I would say, is 30 squared plus 40 squared equal to 50 squared? Again, you're going to type in the left side, hit enter. Type in the right side, hit enter, and see if it's true or false. 30 squared plus 40 squared, enter. Now do 50 squared. Does 2,500 equal 2,500? So this is a yes. This would be a right triangle. I don't see everybody participating. All right, let's do example 3. Based off of this right triangle, which one would have to be side C? 10. So I'll say that's A and B. So I would say, is 6 squared plus 8 squared equal to 10 squared? I'm going to type in the left side, hit enter. I'm going to type in the right side and hit enter. So I have 6 squared plus 8 squared, which is 100. 10 times 10, 10 squared is 100. Does 100 equal 100? Yes. So yes, this would make a right triangle. Now the next one, they're trying to confuse you. They're saying if they put these 3 squares together, would they form a right triangle in the middle? So when I first taught y'all this, I taught y'all that it was based off of right triangles, but I said, everybody look, you don't have to draw this. It's like having 3 squares attached to that right triangle. And Pythagorean theorem says this square, so we'll call this A, plus this square, B, has to equal this square, C. They add up to equal that. So this time they give you squares, and they're saying, hey, if you push these together, would they make a right triangle? Now, where they try to confuse you, everybody look, right here they said 6 centimeters, they gave you the side length. Right here they said 8 centimeters, they gave you the side length, but right here what did they say? Centimeters squared. That means it's already squared. Okay? So you know you don't square that number. So what I'm going to do is I'm going to say the biggest square would have to be side C. And I'm going to say, is 6 squared plus, what would I square this one? If it doesn't have the squared symbol on it, then you have to square it. Okay? Plus 8 squared equal to, would I square this one or is it already squared? So equal to 100. Don't square it. It's already squared because it has that little square right there. Which 6 squared plus 8 squared, we already learned it over here, is equal to 100. So 100 does equal 100. So yes, this would form a right triangle. So I'm going to say that again. If it doesn't have the little centimeter squared, then you have to square it. If it already has it, then you don't square it. Does that make sense? The last thing that you need to know about Pythagorean theorem is that if they use the words distance or diagonal, they're giving you a hint that they want you to do Pythagorean theorem. Yes? So everything you do today is Pythagorean theorem. If they want you to draw lines on a coordinate plane like this, and they say, what's the distance? They want you to draw a right triangle and do Pythagorean theorem. Everybody got it? All right, so open your Chromebooks. Your assignment is going to be called 14-5, and I will get you your answer document.